Graphing inequalities. Notice that we have the form x is greater than 2. We have the solution set, which has a parenthesis on the left, 2, comma, and infinity on the right, then followed by parentheses. Well, let's start out with an open dot definition. Open dot. On graphs, we use open dots to denote that the value will not be accepted as a solution. So, in inequality notation, if you have less than or greater than symbols, in interval notation, if you have parentheses, then both of these case scenarios define that it's not an acceptable solution. So if you see less than or greater than inequalities, it means it's not acceptable as a solution. If you see parentheses, then it also implies it's not acceptable as a solution. Okay, for closed dots, on the other hand, before we graph any, on graphs we use closed dots to denote that the value is accepted as a solution. So inequality notation, therefore greater than or equal to, or less than or equal to. Note it has the equal sign or a single line on the bottom to imply that it's also possible that it could be equal to. So once again, greater than or equal to, or less than or equal to is how we say it. Interval notation. In interval notation format, we use brackets. So if it's an acceptable solution, we use inequalities with an equal sign, meaning a line on the bottom, or in interval notation, we use brackets. Okay, so now let's try graphing some of them. The first one, notice that x is greater than 2. So that one takes an open dot because we have the inequality greater than only. So that does not have an equal sign on the bottom or a single line to imply equal. So we have an open dot. Notice x has to be greater than 2. So you're welcome to try some values. For instance, if you plug in 0, is 0 greater than 2? No, 0 is not bigger than 2. Negative 1. Is negative 1 bigger than 2? Well, let's take the idea. Do you prefer to have a negative $1 bank account or a $2 bank account? Well, 2 is definitely better, right? So it's bigger than, by definition. Okay, so that implies it points to the right. So we draw an arrow pointing to the right. And it goes to the right forever in this case. Hence our solution set in interval notation, we have a parenthesis on the 2 because it's not an acceptable solution. We have a comma in the middle, and then an infinity. Do notice, the infinity sign always takes a parenthesis. So we always have a parenthesis for infinity. Okay, one thing to keep in mind, you always have your lower boundary on the left. For interval notation, your higher boundary is on the right side. So let's try another one. In this case, x is less than 1, so we put an open dot at 1. Notice, x is less than 1. What if we pick 5? Is 5 less than 1? No, so anything on the right side of the 1 would be a false statement, so it wouldn't work, in other words. If you pick 0, is 0 less than 1? Yes, that would be a true statement. So anything on the left side would therefore be true. So let's draw an arrow then. Okay, so it goes to the left side. So do notice, if you have x on the left side of your inequality statement, your arrow points in the same direction as your inequality sign. Notice the previous one, x is greater than 2, points to the right. And this one, x is less than 1, points to the left. So that's how our graph intentionally goes, or is drawn. Now for our interval notation. Notice that it goes to the left forever. So you can put any negative value, in other words. So we have negative infinity on our interval notation format. And then there's a comma in the middle once again. And the higher value in this case is the 1. 1 is the highest value you can use, but once again, 1 is not acceptable as a solution. So that means you can use 0.999999 as far as you want to recall for 9 nines. As long as it gets close to 1, but it doesn't get exactly at 1, it will work. But 1 is not an acceptable solution. Once again, notice that infinity signs always take a parenthesis. So there's a parenthesis on our infinity side, on the left side. The 1 is not an acceptable solution, so we put a parenthesis. Do be aware, you don't have to do both types of notations. You either do in most questions an inequality notation, if it asks you, or you do an interval notation if it asks you. If it doesn't specify, you get to pick which one you want to use. Okay, so let's go for the ones that have an equal sign added to them. Okay, so x is less than or equal to 6. X is less than or equal to 6. Notice, in this case, we should draw a closed dot, agreed? So this should have been a closed dot. And for this case scenario, therefore, we have x is less than or equal to 6. So anything smaller, well, it would be acceptable as a solution. Anything bigger or towards the right, it would not be acceptable as a solution. Once again, it goes to negative infinity. So negative infinity takes a parenthesis. 6. Well, 6 takes a bracket because 6 is an acceptable solution. Do remember, we gotta have a closed dot on our graphing there. Please put a closed dot, minus open. Just a reminder, put a closed dot. Okay, so x is greater than or equal to negative 8. Which way does our arrow point in this case? Let's see. Has to point to the right, agreed? Because of our inequality sign. X is on the left side. So we can always check values as well. Is 5 greater than or equal to negative 8? Yes. So that would work, etc. I'd suggest you try a few more values in there. And notice our inequality sign. The lowest value is negative 8. And it goes to infinity. In other words, positive infinity. There's no negative sign. It's a positive infinity, right? On the left side, negative 8 is an acceptable solution. So we should have a closed dot once again in this case. Please draw a closed dot. And once again, note that in this case, the negative 8 has a bracket, meaning it is a solution. And the x is not a solution. Okay, so let's try drawing a closed dot. There we go. Close dot on that one. And let's draw a closed dot on this one as well. There we go. We've corrected it.